Hello there guys, welcome back to another epic inexorable maths video. We're looking at the Bernoulli distribution today and we're going to do all of it in one go because it is such a simple probability distribution. If you've already done the geometric distribution, you've been following along with my probability playlist, then this is going to be a walk in the park for you. And if you've not, don't worry because this is a fresh beginning here. So the Bernoulli distribution, it's a probability distribution followed by a discrete random variable, and we're going to talk about what it is and everything there is to know about it. So let's begin with the probability distribution. Okay, so what is it? How is the probability distributed across the sample space? Well, let's have a look. So our random variable x can only take the value 1 or 0. It can only take those two values. That's it. What's the probability that it takes either of those values? Well, it's very simple. The probability that the random variable that's Bernoulli distributed takes the value 1 is just some number p. The probability that it takes the value 0 is just 1 minus p, as you might expect. And that is going to actually create for us a perfectly valid, lovely little probability distribution. Here's my wonky table just to, bound it all up and make it look really nice. But this is it. This is everything that there is to know about the way that the probability is actually distributed for a Bernoulli distribution. Okay, and it genuinely is that simple. I appreciate that's a little bit wonky, and of course we need another column there. But let me just speak about this for a second. So things that you can model with something like a Bernoulli distribution is maybe you've got something like a light switch that only turns on, let's say 80% of the time when you flick it. That could follow a Bernoulli distribution, and you would just say on means 1 and off means 0. So you can see how this actually can be quite useful despite being so simple. And of course, you may not know this, but actually it's going to turn out that another much more important probability distribution, the binomial distribution, is kind of built off of the back of this. So even though this looks simple, make sure you really understand what's going on here. That's it, okay? That's literally all there is to it. So the probability that the random variable takes the value 1 is whatever we say p is. P is obviously a number between 0 and 1. And of course, the probability that it takes the value 0 is just 1 minus p. So p is kind of the probability of success, you could say, the probability of successfully turning on the light bulb or whatever. Okay, let's look at the mean and the variance now. So actually, I'm going to stay over here for the mean and variance because the mean and variance, it's really nice to be able to actually look at the table. So what is the mean? Well, guys, we know there's a formula for the mean. The way that we do this, and please do go into the description and check out the video on this if you're not happy with what I'm about to say. But the way that you calculate the mean or the expected value of a random variable, so the expected value of x, the formula for this is it's the sum over the entire sample space, so in this case from x equals 0 up to 1, of the value of x times the probability that the random variable takes that value. That's the formula, that's the definition actually of the expected value or the mean of a discrete random variable. So in this case, it's just going to be when x is 0, so 0 times the probability that x equals 0 plus 1 times the probability that x is 1. And guys, we can't really get much simpler than this. The probability that x is 1 is just p. So this, of course, just ends up being p. So the expected value of a Bernoulli distribution is just p, which is the probability of your success. Nice and simple. What about the variance? Okay, well, guys, remember the variance, and again, I've got a video on this too. The variance is the expected value of x squared like this minus the expected value of x and then squared. Okay, this is the variance of our discrete random variable. This formula is also true for a continuous random variable as well, but we don't care about that. And of course, we just need to calculate the expected value of x squared. The way that we do this, I won't write it down, but I do have videos on it, is we do a very similar thing. So the expected value of x squared like this is just going to be each value squared, like each x value squared, 1 squared and 0 squared, times their respective probabilities. So it's just going to be 0 squared times 1 minus p plus 1 squared times p. And of course, this ends up just being p again. So then what we end up having is that the variance in this specific case here is p minus p squared, okay? And that, of course, we can say that's p times 1 minus p if we want. So that's the variance of a Bernoulli distributed random variable. So now we have the mean and the variance. The mean is p and the variance is p times 1 minus p. If you want the standard deviation, of course, that's just going to be the square root of p times 1 minus p, because the standard deviation is the square root of the variance. Okay, cool. That's the mean and variance. Now let's have a quick look at a worded example. So I reach into a bag containing 5 red balls and 10 blue balls. Let x be a random variable that takes the value 1 if the ball is red and 0 if the ball is blue. First of all, what is the probability that I take a red ball? So before we even answer this, let's just recognize that this is a Bernoulli distributed random variable. It takes the value 0, it takes the value 1 with we can work it out, but a clearly defined fixed probability of success, p. We can say by convention that the probability of a success is the probability of getting ourselves that red ball. Hopefully that makes sense. So there's 5 red balls and 10 blue balls. That's a total of 15. So 5 out of 15 is the probability. Okay, so the probability of getting that red ball, which is also the probability that x takes the number 1 here, okay, because it's Bernoulli, is just going to be the p, the probability, which is, of course, again, 5 out of 15. 5 out of 15, or if you prefer, 1 out of 3. That's not rocket science. Okay, second part, find the mean and variance of the random variable. So let's just remind ourselves what the mean and variance actually are. That's actually a gross color. I'm going to change the color. So let's go this color here. So the mean, the expected value of x, which is also the mean, is just p, and the variance of x, which is also written as sigma squared, is p times 1 minus p, of course. So now we just plug these into our formula and we're done. So cool. So the variance, or let's do with the mean first. The mean, the expected value of x, is just the probability of success, which is 1 in 3. And the variance of x is just 1 in 3 times 1 minus 1 in 3, like that. And that's 1 in 3 times 2 in 3. That's 2 out of 9, okay? So that's what that means, and that's how that works. That is pretty much everything that you need to know about the Bernoulli distribution, at least for now. Okay, we can talk about more complicated things, but we don't need to right now. So hopefully that was helpful, and I highly appreciate you guys watching all the way to the end. You know that. Quick friendly reminder, there's never, ever, ever any mid-roll ads on this YouTube channel, because I turn them off, because I don't believe that you should be watching a mid-roll ad when you are coming to YouTube to watch an educational maths video. So please do bear that in mind, and if you ever see one, leave a comment on the video and I'll come in and delete it for you. Thank you so much for watching. As always, I highly appreciate it, and I'll see you in the next one. Cheers.